So last year in Algebra 2, you did work with the law of sines and the law of cosines. But in terms of the ambiguous case, I think it was briefly mentioned, but not really did any detail or did any problems with the ambiguous case. So we're looking at those today. Remember, yesterday on your homework, you really didn't have to think too hard about should I be using law of sines or law of cosines, because they were all law of sines problems. And we didn't know about the ambiguous case yet, so you never had to worry and check for, is it a regular law of sines or is it the ambiguous case? So each day, today and on Monday, when we add something new, that's something for you to think about at the beginning of a problem so that you get the correct solution. Okay. How do you solve a triangle that's not right? You know, if you think back to chapter 4, we were always solving right triangles, so we were using Pythagorean theorem, we were using SOHCAHTOA, we could find angles, we could find side lengths with those tools. What are we going to be using in place of Pythagorean theorem and SOHCAHTOA for the non-right triangles? Already we have law of sines, and we'll also have law of cosines eventually. What you did yesterday were all law of sines problems, and I didn't mention this yesterday, but the only types of law of sine problems on your homework were angle, side, angle, or angle, angle, side. So if you go back and you look at your homework that we just went over, you're always finding the third angle and the two other sides. Okay? If you run across cases of angle, side, angle, or angle, angle, side, you can just set up the law of sines, and you're always going to have one solution. You'll have a triangle, solve for it, be done. Okay? Today, we're going to look at the case of side, side, angle, okay, where you get two sides and one angle, and this is the ambiguous case. So yesterday, when I would start a problem, I said, you know, eventually you're going to have like law of cosines mixed in here, and like how will you decide if you're doing law of sines or law of cosines? I usually check to see if I can use law of law of sines. Do I have one angle and the side opposite that angle? If I have a matching pair of a corresponding angle and its opposite side, I can use law of sines. If you say, yes, I have one angle and an opposite side, now you want to add a check to that. Do you have two angles and a side, or do you have two sides and an angle? If it's two sides and an angle, this is the ambiguous case. Remember, we can't spell this backwards because it spells a bad word, right? But that's how I remember that that's the ambiguous case. The ambiguous case is bad, like I don't want it because I don't know what's going to happen. And so that's how I know that I'm going to have ambiguous case. Spells a bad word. Okay. Now notice that that side-side angle is different than side angle side, which we looked at yesterday in terms of that area formula. Two sides and an included angle. This is going to be two sides and a non-included angle. And side angle side, if you're trying to solve the triangle, not find the area, it's going to be law of cosines. So law of cosines on Monday is going to do side, 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 and side angle side for you. Yes.
Why couldn't you like fill it in with the angle, like the sine of the angle and the opposite side, and then like x for the sine above it, and then the one below it, and then just take the inverse of the.
Well, we'll be able to solve, but it's ambiguous. Are you talking about side, side, angle?
Yeah. Like,
yeah, we're going to do that. We're going to use inverse sine, for sure. Yes. I'm going to show you on the next slide, and you don't have to write anything down. Just kind of like be watching and be present and understand why this case, side, side, angle, is ambiguous. Okay. So I have a GeoGebra file, and this link will be on my notes that I post if you want to go to it and play around with it. And what it does is it gives you a triangle, or the setup for a triangle, in terms of the ambiguous case, which is side, side, angle. So notice that I have one angle here, angle B. It is 56 degrees. I have one side. This would be side C, because I have angle A and angle B. Wherever I make a triangle, that's going to be angle C. Okay. So I know side C is 7. And I also know the side opposite of B, that's 10.4. So side B is 10.4 right now. So I have a side angle. The angle is not included in between the two sides. So it is not side angle side. Okay. I have drawn this ray from angle B, right? And it extends forever. But what we want to do is we want to take this red X, do it on my computer, take that red X and move that side that is fixed at 10.4 and try to create a triangle with that angle. So can you see how I'm coming down here and I would make a triangle? Okay, and so the stuff to the right of this wouldn't be the length of B. We would just say B is this side right here. Okay, but I've got one triangle right there. Okay, so that's a case of side angle, and I've created a triangle. And if I keep swinging that side, the red X is just too long to make another triangle. Okay, so there's only one triangle in that solve. It hits that ray just right there. Perfect. Okay, so that's a case of one solution. Now, if I can change any of those things, I'm just going to change the fixed side that we're swinging around. So that's side B. I'm going to make it shorter. And could you imagine, let's say angle B was 56, side C was 7, and side B was 3.4. Is there anywhere where you could move that side and create a triangle? No, it's way too short to make a triangle. So this is an ambiguous case of side angle where no matter where I move that side, it's never going to reach this ray that would give me a 56-degree angle right there at angle B. So now I know ambiguous case means I could have one solution or I could have 0 solutions. Okay. Then, if I change B again, and I got to get it in just the right range, so if I change B again, then I made it 6.3 now, I'm going to swing it around. I'm creating one triangle right there. Do you agree with that? Okay. And if I continue to swing this around, I'm going to cross that line one more time, so there are really 2 triangles. So what does ambiguous case mean? If you know 2 sides and an angle that is not included in between the 2 sides, there are 3 possibilities. There is no triangle, there is one triangle, there are 2 triangles. You don't know which one it's going to be until you do the math. So that's the ambiguous piece of that. Now, before we go on and we actually do an example, I just want to call to attention this example right here. If I move back to this other triangle right here, remember this is angle C over here at the red X. You know, I could estimate the measure of angle C right here. I could also classify it. If I classified it in terms of angles, what type of angle is this? It's an acute angle. It's less than 90 degrees. Maybe I would measure it like 70 or 80. Okay. Now, if I go back to that other spot where I can create the second triangle, what are you noticing about your new angle C? It's now an obtuse angle. And if I estimated that angle, I might estimate it at like 100 or 110. So the key to finding the 2 triangles is that if 2 triangles exist, that angle that you're finding is going to be a supplement. So like if that one's 70, then the other one's 110. And then you can solve for the rest of the triangle. So we're going to focus on that angle would have to be a supplement to that acute angle. Let's look at some examples. Here's example 1. Remember, I'm just copy and pasting my same old triangle from yesterday because I'm lazy. And obviously this is not drawn to scale. Angle B is not look like 33 degrees, but I don't care. So it doesn't really matter what your triangle looks like. Angle B is 33, side A is 23, and side B is 14. if this were like a regular problem on my review, on my quiz, on my test, and it's mixed in with all other solving triangles, like I have to do a little bit of prep work at the beginning. Should I use law of sines or law of cosines, right? Okay. Since I know angle B and side B, an angle and its opposite side, I could use law of sines. Okay, so I'm going to use law of sines. And then now that you know about the ambiguous case and that it only happens if it's side-side angle, you're going to look and see if you have that bad case, right? So I have one angle, I have two sides, it's the non-included angle. So this is an example of side-side angle. So now I know it's ambiguous. I've got to do a little bit extra work. Generally, the work is still the same. So, you know, that whole piece of I know one angle and its opposite side, let's set up that ratio, right? Sine of 33 over 14 equals the sine of angle A over 23. We are going to have to tweak our solving just a little bit. We're going to cross multiply and we're going to divide, but then in order to break into the sine of A, we're going to have to do an inverse, okay? So I'm going to show my work for cross multiply on this one, but I usually won't do all of my work. If I cross multiply, I'll get 14 sine A equals 23 times sine of 33. I'll divide both sides by 14. So I have the sine of A equals 23 times the sine of 33 over 14. And like Kate had mentioned at the beginning, we're going to do an inverse sine. So you can write arc sine, or you can do the sine with the -1. Now, I'm going to encourage you to try to avoid rounding for as long as possible. So you can really type all of this into your calculator at the end. Sorry, I covered that up. Remove it. Close. No. No. There it is. Okay. So I can really type all of this into my calculator at one time. So I'm going to do the second sine. If you're solving for an angle, you're going to use the inverse. And then I'm going to do 23 times the sine of 33, close my parentheses, and then I'm going to divide by 14. And I don't have to worry about having rounded my answer at all. If you're rounding, if you're doing 23 sine 33 and getting a decimal, and then dividing by 14 and rounding that again, and then doing the arc sine, you're probably going to be a couple hundredths off. Okay. Everybody's calculator working okay here? Okay. So keep solving like normal. Now, after you find angle A, find angle B. No, we already know angle B. Find angle C. Angle B was 33 minus 63.48. And then I'm going to show you real quick on your calculator a trick for like not having to round. So, you know, pulling up your previous answer. If you ever want to reuse this answer, 63.478, I'm going to do 180 minus 33. And then rather than having to type that answer, if you do second, and then the negative sign, it says ANS right above it. It's gonna, the ANS is gonna substitute whatever your previous line was. So it's gonna put in all those digits, 63.4781487. And then I don't have to worry about rounding. Check your mode, Maggie and Nadine. 83.52 degrees. Let me know if your calculators are not giving you the answers that you want. I will come over and assist you. And then just like yesterday, now you can solve for side C. So I'm going to go back up to my very first set of work, and I'm going to pull this ratio, the sine of 33 over 14. That's the one that doesn't have any rounding in it, so I like to use it because it's going to be exact. The sine of 33 over 14 is equal to the sine of 83.52 divided by side C. So now I'm going back to, like, I don't usually write out all my work with my cross multiply. I would get 14 times sine of 83.52, and then I know I'm going to have to divide by the sine of 33. So I'll just write that out. And then again, I can use, and it's kind of like a shortcut, I can use that answer button in my calculator because I just found 83.52. So then I don't even have to round that answer in my calculator. I'm going to type in that line for C. That's 14 sine, and then I'll just put in my answer, second negative. Close my parentheses, divide by sine 33. I'll get 25.54. Is everybody okay with this? Okay, so really, other than kind of like what Paige talked about when we were looking at the ambiguous case, you know, the solving really seems very similar. Of course, in that first one, you have to do an inverse sine to find the angle. Okay, but what you just did right here is solve for one triangle. Okay, so I'm going to go back up here to my start of my work, and I'm going to say this is my first triangle. Because I identified this in the very beginning as side-side angle in the ambiguous case, then I know there could possibly be a second triangle. Okay. Now, to find your second triangle, we're going to go back to that idea when I was moving that one that had two triangles, and I said, what can you say about this angle? It's acute. What can you say about this angle? It's obtuse. And if we even estimated, we'd probably say they were supplements of each other. So let's go to the first angle you found. It's always got to be the first one. The first angle you found was angle A. If there is a second triangle, the second triangle's angle A will be the supplement to this angle. So how would you find its supplement? 180 minus 63.48. Okay, so let's restart this work for a second triangle. Sorry.
Can you say that again?
Yeah. If a second triangle exists, the angle A in the second triangle, and it will not always be angle A, it's just whatever the first angle you solve for is. But that angle in the second triangle will be the supplement. So I'm going to put on my arrow, find supplement. And what do you guys get for the new angle A? 116.52 degrees. Okay. So, if the second triangle exists, these things are true. Angle B is 33, side B is 14, side A is 23, and then angle A, the first angle we solved for, would be the supplement, okay, 116.52. And then we would do just like we did before, which was find angle C next. Okay. Now, in the second step of your second triangle, this is when you'll find out if a triangle actually exists. Can you do 180 minus 33 minus 116.52 and get another angle? Yeah. So then there is a second triangle. What is that measure for C? 30.48 degrees. Now, how will you know when there is not a second triangle? When you do this subtraction and you don't have any degrees left over. Like if it's more than 180, you can't have that triangle. So if you do this subtraction and get a negative answer, no second triangle, move on. Then, after you find angle C, find side C. Same process. Sine of 33 over 14 equals the sine of the new C, 30.48, over side C. Cross multiply, divide to solve. And when someone gets an answer, let us know. Here's 100. 13.04. If at any moment your calculator isn't giving you these answers, let me know. We'll come by and look at it. So we're able to actually solve a second triangle. This is what I would say to you. When you're taking a quiz or a test, if it's law of sines, check for side-side angle, bad word. If it's a bad word, assume there are two triangles. Just always assume there will be two, and when you do that check, you'll find out if it's true or not. You can go into your textbook, and there's like a box with a long list of like, if this side is greater than this side, and the height is less than this, and it's an acute or an obtuse triangle, then there will be one solution, or two solutions, or no solutions. But like, I would never be able to remember all that. So if you don't want to check the second triangle, you could memorize those things, but I think it's more work than necessary. Okay, so I always assume the second triangle and see if it works out. Any questions? Will you please work out example 2 for me on your own? Can someone who found angle C give me your angle measure? 33.52. Thank you. Which makes angle A 67.48. Nine. And what did you get for side A? 15.06. Are we in agreement with all of those measures? Okay. So, everything is working out. We're finding one triangle. We've got two angles and one side solved. But because in the beginning we would recognize this at side angle, we would say that's ambiguous. So now I know that's my first triangle. I've got to solve for my second triangle. Second triangle. Go to the first angle that you solved for. 33.52. Find its supplement. What is the supplement there? 146.48. Yep. So that's my C. And then, if I wanted to find A, I would do just like I did here, which is subtract the two angles that I know. So I would do A equals 180 minus 79 minus 146.48. And you're going to run into what problem? You get some kind of negative number, which your angle inside of a geometric triangle cannot be negative. So there is no second triangle. Stop working. So again, there's like this piece. Know that it's side angle. Know that that might mean extra work. So always assume the second triangle exists. If no second triangle doesn't work out, then you can stop working on it. Right. It's not always angle A. You know how when you set up your law of sines at the very beginning, you do one ratio filled in and you solve for an angle here? It's whatever the first angle you solve for is. So never use this second angle. Always use the first angle you solve for. Because that's the angle, that angle C, when I was like moving around that side, that's the one that's changing. C is changing, the one we're solving for. But angle A is dependent on C. Does that help you out? Okay. Any other questions or concerns? Okay, got one more. Yay! Yeah, it won't take you long. In this triangle, side or angle C is 85, side C is 15, and side A is 25. People are typing it into their calculators. There's a little murmur going around. What's happening? You're getting domain errors in your calculator. That means there is no triangle. No solution. Can someone in their triangle type in just this stuff in parentheses? 25 times sine 85 over 15. Okay, 1.66 Maggie says. So what's happening there is you're trying to take the inverse sine of a number greater than 1. And if you'll remember from your sine wave in chapter 4, it, like for its parent graph, it had a maximum value of 1 and a minimum value of negative 1. So anytime the ratio is outside of negative 1 to 1, then you're going to have no solution. There is no triangle that would have that sine value greater than 1. Okay, so isn't that one awesome? Yeah, okay. So now you've seen all 3 cases of ambiguous case. If you can solve one triangle, assume there's a second triangle. It may or may not work. If you can't even get one answer, double check your work, but it may be no solution. So you've got about 10 minutes here. You can get started on your 8 to 10 question assignment. Some of those are going to be no solution. So that's going to be great. Okay. I'm not sure if there are ambiguous cases mixed with like non-ambiguous cases. So just as a quick reminder, if you saw a triangle and you could use law of sines, but you need 2 angles and 1 side, you would never have to check for a second triangle. You only have to do that for side-side angle.